Hello, my dear students. I hope you all are doing well. My name is Mansi Gupta, and today we are going to start with a new chapter, that is metals and non-metals. So, if you see here, we have around 118 elements in total, and out of them, 90 are the metals, right? We generally see that this right portion is the part of the non-metals, and most of this left portion is the metal part. If you see here, there are some elements which you are very much familiar with, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, right? There are like zinc also, silver, gold, right? Platinum is also there, correct? Manganese, cobalt, iron, nickel. So there are some elements out of which we say maximum are the metals. 90 of them, 90 of 118 elements are the metals. Rest are the non-metals or metals. We'll discuss about what are metals, non-metals and metalloids. So it was a kind of a map for you how we can see the metals, how many are the metals, why are metals and non-metals important? Because if you wake up, you will see you are surrounded by metals and non-metals and the compounds made by them. Your devices are made up of metals and non-metals. The study table, your pencils, pens, right? The air you breathe, oxygen is a non-metal. The air you breathe out, that is a non-metal, a compound of a non-metal, carbon and oxygen, carbon dioxide, right? So metals and non-metals play a very important role in our life. Let's continue. As I told you, there are 118 chemical elements known at present, out of which 90 elements are metals. On the basis of their properties, all these elements can be classified into metals and non-metals. How we can classify? On the basis of their physical properties and chemical properties, right? So first, we'll take an idea about metals, then we'll define, after learning what are metals, we'll give a definition to the metals. Same with non-metals, first we'll understand what are non-metals and then we'll define them. Then we'll differentiate, we'll learn about their physical properties also. Okay, so coming to metals, metals are elements except hydrogen which form positive ions by losing electrons for donating electrons. Now, if you see here, coming to hydrogen, right? If we take hydrogen, atomic number for hydrogen is 1 and it only has 1 electron, right? Hydrogen can form H positive by losing an electron and H negative by gaining an electron, right? Hydrogen is generally found in proton form, but it is considered as a non-metal. Okay? Because it does not satisfy all the categories, all the characteristics of metal, we consider hydrogen as a non-metal. Coming to next, we have lithium. Now, lithium is a metal. If you see, the atomic number for lithium is 3. So, it is 2, 1. So, to complete its duplet, right, it will lose 1 electron and it will become Li positive with 2 electrons. Coming to, let's see, sodium. Now, sodium has atomic number 11. The electronic configuration will be 2, 8, 1. Again, it will lose the electrons and it will become Na positive with electronic configuration 2, 8, completing its octet. Right? Now tell me, why are we writing positive if the electron is losing? Okay. In a particular atom, if you see, protons are in the nucleus. So it is not like that the proton is exchanging. The chemical reactions, the loss and gain will always be of the electron, not of the proton. If you see here, we have atomic number 11 in case of sodium, right? That means 11 protons and 11 electrons. Also, one positive, one proton and one electron. Basically one positive charge and one negative charge will neutralize the charge, right? There will be no charge. They will cancel each other. So here, when we talk about atomic form or elemental form, in this form, 11 protons and 11 electrons, number of positive charge and number of negative charge is equal. That's why this is a neutral atom. But if we see Na11 in the positive form, but if we see sodium ion, we have 11 protons because protons haven't gone anywhere. We haven't shared anything or gained any proton. But we have 10 electron, 1 electron we have lost. We have donated 1 electron. So if you see 10 protons and 10 electrons will balance each other, but we have 1 extra proton, the 11th proton, right? Which we are representing here in the case of sodium. So the metals which tend to be the positive ion, they tend to form the positive ions by donating the electrons are known as metals. Okay. Same case with the magnesium. If you see magnesium, aluminium, magnesium is atomic number 12, right? 2, 8, 2. Now again, number of protons, 12 protons, number of electrons, 12 electrons. If I lose these 2 electrons, I'll be left with 10 electrons, correct? So 10 protons will balance the number of 10 electrons, but the 2 protons will cause the charge, that is Mg2 positive. So do you understand that this charge, this positive charge is not due to protons, this positive charge is due to loss of electrons, not due to gain of protons, no. Coming to aluminium, atomic number for aluminium is 13. Electronic configuration 2, 8, 3, right? Again, for the octet rule, for the stability, it will lose its 3 electrons and the new electronic configuration will be 2, 8. Again, 13 proton, 13 electron in the neutral atom, but when it will lose 3 electron, we are left with 13 protons and 10 electrons. Again, we have 3 extra protons, that is 3 extra positive charge, which we are representing here on aluminium. When we will study about non-metals, I will explain you how the non-metals have negative charge. I hope you understood the value why we put this positive, positive 1, positive 3 on certain elements. For example, metals. So, metals are the elements except hydrogen which form positive ions by losing electrons or by donating electrons. Next, metals are electropositive elements because they can form positive ions by losing the electrons. Electropositive elements, okay. So metal are known as electropositive elements, which the elements which are ready to be the positive ions, right? They are ready to give the electrons. To take these electrons from me, that is your electropositive element. Now we have physical properties of the metals. Physical properties, when you see the metals, how you can observe the metals on the basis of their physical properties. Metals are malleable, that is, metals can be beaten into thin sheets with hammer without breaking. For example, nowadays the festivals are coming, so you will see the shiny silver coating or shiny silver foil on the sweets. That is very thin, right? Beating the metal so that they turn themselves into thin sheets. They are not brittle. We hammered it and it is brittle, it is powdered. No, it won't be powdered. It will turn itself into the thin sheets. For example, like the aluminium foil, as I gave you the example of silver foil, gold foil used in jewelry. Correct? If you see in this image, we are hammering a nail and this is not breaking. It is flattened, right? It is turning into thin sheet. Same with the aluminium wire. When we beat it is turning into flattened sheet. And where we were hammering, the nail and the aluminium wire are flattened. Okay. Second point we have is metals are ductile, that is metal can be drawn or stretched into thin wires. You can see here ductility, how we are forming wires from the metals, right? Here also you can see how copper wire has converted itself into thin wires. This property of the metal to form them into thin wires, that is known as ductility. So if we say, what do you understand by the word malleability? Basically we can say the property which allows the metal to be hammered into thin sheets is called malleability. We have two metals which are highly malleable in nature, that are gold and silver. That's why we make beautiful jewelries out of them. Aluminium and copper metals are also highly malleable. So wherever we need the thin foils at an economical price, then we use copper or aluminium. Okay. Now coming to metals are ductile, that is metal can be drawn or stretched into thin wires. So what is ductility? The property which allow the metal to be drawn into thin wires is called ductility, right? Gold is again also the most ductile metal. After that we have copper, aluminium metals which are also ductile and used in the form to make the wires. The wiring in our home appliances, that is made up of copper or aluminium. Do you know that if we take 1 gram of gold, we can draw 2 kilometer long wire out of it? So from these 2 points, we got to know that metals are highly malleable and ductile in nature. After that, metals are good conductor of heat. For this, we have one activity to prove. जैसे यहाँ पर इस एक्टिविटी में देखो, this is an aluminium rod, obviously a metal. यहाँ से we are providing it a heat from the Bunsen burner. हमने क्या किया, यहाँ पे वैक्स को लगाया, वैक्स को लगाकर आयरन उस पे पेस्ट कर दिया, आयरन नील उसमें पेस्ट कर दिए. अब जैसे जैसे यहाँ पर हीट प्रोवाइड हो रही है, टेम्परेचर राइज हो रहा है, इफ इट वुड बी अ नॉन कंडक्टर ऑफ द हीट, सिर्फ इतना ही हिस्सा या तो इट माइट हैव बर्न, ये तो जल जाता, या फिर हीट यहीं तक सीमित रहती. बट वी सॉ दैट एज द टाइम इज पासिंग, धीरे धीरे जो है नील्स नीचे गिर रहे हैं. नीचे नील्स क्यों गिरेंगे? कि जो वैक्स है यहाँ पे वो मेल्ट हो रहा है. मेल्ट क्यों होगा? बिकॉज ऑफ द राइज इन द टेम्परेचर. सो वी गॉट टू नो कि हीट इस पॉइंट से दूसरे पॉइंट तक क्या हो रही है? कंडक्ट हो रही है. So in the metals we see that the heat is conducting, okay, which proves that metals are good conductors of the heat. और यही this property that we use in the kitchen also. Utensils generally metal के बने हुए होते हैं, right? ताकि वो अच्छे से heat को conduct कर सके और we are able to cook our food and it does not get burned. Okay. Now, metals are lustrous or shiny and can be polished. Because of this lustrous and shiny property, we are using the metals for making the jewelry, right? So, what we can say that the property of metals having the shiny surface is called the metallic luster. हम बोलते हैं कि चमक रहा है, तो jewelry बनाने में ये काम आता है, right? Experience because of excellent luster, because of its shining property, we see that it is used in making the jewelry. We have one more metal, that is silver. Again, because of its shining property, acting as a good reflector also, we use the silver layer, right? The layer of silver behind the mirror. So we can say silver metal, being an excellent reflector, is used for making the mirrors. Coming to next point, metals are generally hard except sodium and potassium, which are soft metals. Metals generally hard होते हैं. ऐसे नहीं होता कि आपने मेटल का रॉड लिया या फिर आयरन नेल भी लिया, या प्रेसिंग इट बाय योर हैंड या फिर नाइफ से उसको कट करने की कोशिश कर रहे हो, इजीली कट हो रहा है. बट सोडियम एंड पोटेशियम वी सी इजीली, दे आर सॉफ्ट मेटल्स और वो इजीली कट हो जाते हैं. दिस इज अ सोडियम मेटल कटेड बाय द नाइफ. Metals are solid at room temperature except mercury, which is liquid metal. ये जो सारे exceptions हैं, हम एक बार इनको दोबारा से डिटेल में अलग से पढ़ेंगे when we complete the physical properties of metals and non-metals. So यहाँ पे metals are solid at the room temperature. कोई भी ऐसे नहीं होता मेटल के रूम पर लिक्विड फॉर्म में है एक्सेप्ट द मर्करी दैट वी यूज इन द थर्मामीटर, वो लिक्विड स्टेट में प्रेजेंट होता है. Metals have high densities because they are heavy. Metals have higher density again except sodium and potassium. Sodium and potassium are lighter, right? Let's say for example, the density of iron is around and approximately 8 times more than that of water. If I keep a iron laying in water, it will sink, right? Because its density is more than that of water, right? The density of sodium and potassium is less than that of water. Approximately 0.9798 is of gram per centimeter cube is of sodium and approximately 0.86 gram per centimeter cube is of potassium. Metals having high melting point and boiling point. Why metals have such high melting point and boiling point? If we see, metals are generally present in solid form, means there is a negligible distance present in the two atoms of metal element, right? So there is very strong force of attraction between the particles. If I apply huge amount of heat, then only this bond will break, right? So to break this bond, because if I am doing the melting point, it has to be converted into liquid state, and when it is going to the boiling point, it has to be converted into gaseous form, right? So I have to provide immense amount of heat to break this bond, break this metallic bond, to convert it into so that the interparticle distance increases and it converts its physical state into liquid form. Later also I have to provide again immense amount of heat so that they are present in the gaseous form for the boiling point. That's why they have very high melting point and very high boiling point. If I give you the example, the melting point for the iron is 1535 degrees Celsius, right? So if I provide the temperature above 1500, right, then only the solid liquid will turn itself into the molten state, correct? If we say copper metal is also having very high melting point. It is 1083 degrees Celsius. Whereas if we see sodium and potassium exception, then sodium and potassium as compared to metal, they have still higher melting points and boiling point, but as compared to the other metals, they have lower melting and boiling point. For example, the melting point for sodium is 98 degrees Celsius and the melting point for potassium is 64 degrees Celsius. There are two more metals, that is gallium and cesium. They have very low boiling point. The melting point for gallium is 30 degrees Celsius and melting point for cesium is 28 degrees Celsius. If you at the normal temperature, gallium will be in the solid form, but if you put gallium in your hand, because of the body heat, it will melt. Okay, it will start melting in the hand. Now metals are sonorous, the ringing sound produced by the metal, the property of the metals to produce the ringing sound, right? So that ringing sound is used to make the ghungroos, that ringing sound is made to use the anklets, that ringing sound is made to use the bells, right? So what we can say, the property of the metals being sonorous or produce the ringing sound is called sonorousness or sonority. Clear? So we can say that the property of the metal to being sonorous or to produce or to make the ringing sound is called sonorousness or sonority. It is due to the property of the sonority, the metals are used for making bells, strings of the musical instrument like sitar, violin, guitar, right? Then about the appearance, metals usually have silver or grayish in nature except copper. We all know golden color, the shiny color of the gold and the brownish color of the copper. Now if we define the metal on the basis of their physical properties, so we can say metals are elements that conduct heat and electricity and are malleable and ductile. Metals are lustrous, that are shiny, hard, strong, heavy and sonorous, which making ringing sound when struck. Some examples of metals are iron, aluminium, copper, silver, gold, platinum, zinc, tin, lead, mercury, etc. There is one more exception. Lead is a metal which is not much shiny. Okay, so this was about metals. Now we'll start with non-metals. So what we can say, non-metals are elements which form negative ions by gaining of electrons or accepting electrons. For example, oxygen is a non-metal and it forms negatively charged oxide ion O2 negative by gaining the electrons. Non-metals are known as electronegative elements because they can form negative ions by gaining electrons. There is, however, an exception. As we discussed in metals also, hydrogen is the only non-metal which loses electron to form the positive ion, that is H plus ion. Okay. Now if we talk about negative ions, let's say for example, let's take oxygen only. The atomic number for oxygen is 8. So electronic configuration will be 2, 6. If it has to complete its octet of the nearest noble gas, so it has to gain 2 more electrons, right? So it will be O2 negative and electronic configuration will be 2, 8. Now again if you see, in the neutral atom, number of protons and number of electrons are equal, that is 8 and 8. Now in the ion, oxide ion, number of protons will be same, but now the number of electrons are 10, right? So 8 protons and 8 electrons will neutralize each other, but these extra 2 electrons will give us the charge, right? Same with the chlorine. If we say chlorine atomic number 17, so the electronic configuration for chlorine will be 2, 8, 7. So to complete its octet for having stable electronic configuration, it has to gain 1 electron, right? Chlorine 17 negative charge, if we see 2, 8, 8, right? Now if you see, what will happen? That we have 17 protons and 17 electrons in the neutral atom. But here we have 17 protons and 18 electrons. Extra 1 electron will be giving us the charge. So I hope you understood that the charges on the element is due to gain or loss of the electron, not because of the proton. Now if we talk about the electronegativity, so non-metals are known as electronegative elements because they can form negative ions. The property of the non-metals to form the negative ions is known as electronegativity. Okay. Let us discuss now for the physical properties of the metals. So unlike metals, non-metals are neither malleable nor ductile. Non-metals are brittle. They break easily. So if you see here, जब हमने metals को hammer किया था, तो वो easily क्या कर रहे थे? Flatten हो रहे थे. लेकिन जब हमने coal को या फिर pencil lead को hammer किया, so they broke into pieces. Powdered form में turn होने लगे. Correct? Non-metals do not conduct heat and do not conduct electricity, that we all know. Plastic से या wood से heat या फिर electricity conduct नहीं होगी. Non-metals are not lustrous, they are not shiny, they are on the dull side. Non-metals are generally softer except diamond. Diamonds are extremely hard non-metals. Non-metals can be solid, liquid or gas. Solid is say for example carbon. This is diamond. Diamond is a form of a carbon. Coal is a form of a carbon. Graphite is a form of a carbon. Liquid mein we have bromine. Bromine is present in the liquid state. Bromine water, that is called. Then gases, oxygen gas, chlorine gas, nitrogen gas, helium gas. So we have solid, liquid or gases at the room temperature. Non-metals have comparatively low melting point and boiling point except diamond. Diamond has a very high melting and boiling point. For example, we can say, and this is we are saying in comparison with the metals. For example, the melting point of sulfur is 115 degrees Celsius, right, which is quite low as compared to the other metals. Diamond, as we discussed, diamond has a very high melting point. It is more than 3500 degrees Celsius, which is very high. Coming to next point, Non-metals have low densities, that is non-metals are the lighter substances as again compared to the metals. For example, the density of the sulfur is a yellow color compound, which is the density for the sulfur is 2 gram per centimeter cube again as compared to the metals. Non-metals are sonorous. They do not produce sound when hit the object, right? If you hit on the wood or hit on the plastic, you will not get that ringing sounds on the metal. Now, these are some exceptions. As I told you, we will discuss the exceptions of metals and non-metals separately. So, we have electric conductivity. The exceptions in electric conductivity, we have studied that non-metals cannot conduct electricity, but we have one non-metal, that is carbon in the form of graphite. Carbon in the form of diamond, again it is a non-conductor. Carbon in the form of coal is a non-conductor, right? But carbon when in the form of graphite, it is a conductor of electricity because it has the free electrons to conduct the electricity. Thus, graphite is a good conductor of electricity just like metal, but it is a non-metal. Luster, we have studied that non-metals do not have luster. They have done appearance, but we have iodine and graphite which are non-metals and which are lustrous in nature, having shining surfaces. Iodine has more shine or more luster as compared to graphite, but if you see your pencil tip, you will see some shining there. That is because of the graphite. Coming to third point, that is hardness and softness. So we have studied that metals are hard in nature, but we have discussed alkali metals like lithium, sodium and potassium, which are soft, which can be easily cut by the knife. We have studied that solid non-metals as compared to the metals are on the softer side, but carbon in the form of diamond, it is very hard, right? It is a non-metal which is extremely hard. Physical state, we have studied that metals are solid, but at room temperature, mercury is in liquid state. Coming to next point, that is melting points and boiling points. We have studied that metals have high melting point and boiling point, but again the exception is sodium, potassium, cesium, gallium. Metals have low melting point. Just like non-metals, we have studied that non-metals have low melting point and boiling point. If we talk about gallium and cesium, they have lesser melting point, means even lesser than sodium and potassium. As we discussed that the melting point for the cesium is 28 degrees Celsius and melting point for the gallium is 30 degrees Celsius. So if at room temp, we can say approximately at room temperature, generally we take room temperature that is 25 degrees Celsius. So whenever there is mentioned room temperature, it means around 25 degrees Celsius. So above room temperature, that is 30 degrees Celsius and 25 degrees Celsius, if you provide gallium and cesium the heat, they will melt easily. Non-metals, we discussed that non-metals have as compared to metals lower melting point, but we also discussed that diamond being very hard, it has very high melting point and boiling point around 3500 degrees Celsius. Then coming to the last point for the exception, we have density. So we studied that metals have higher density, but again alkali metals, the lithium, sodium and potassium are the exceptions. They have low density just like the non. So from this above discussion, we discussed that okay, metals have different physical properties and non-metals have different physical properties, but we cannot classify it like yes, this is a particular metal because luster, if we take iodine is lustrous in nature, है ना? तो हमने क्या किया, फिजिकल प्रॉपर्टीज के बेसिस पर तो क्लासिफाई किया ही, वी क्लासिफाई देम ऑन द बेसिस ऑफ केमिकल प्रॉपर्टीज आल्सो, ठीक है? So chemical properties we'll discuss in the coming chapter. Before that, from the today's topic, what we have understood, we'll take a summary and some important questions that can come from the topic that we have studied. Clear? So if you want to do a comparative study of metals and non-metals on the basis of their physical properties like luster, hardness, physical state, malleability, ductility, conductor of heat and electricity, density and melting point, boiling point and sonorous. This is the chart for you. You can take the screenshot. You can, if you want, you can pause the screen and write it down. Then we have the points. The question can come differentiate between metals and non-metals on the basis of their physical properties. So this chart will help you again. 5 points are there, 5 markers, 3 markers can come from this part. These are some practice questions for you. Question 1. From amongst the following, choose the metals and non-metals and state one of the properties on the basis of which you have made your choice. We have graphite, sodium, phosphorus and helium. Name one metal and one non-metal which exists in liquid state at room temperature. Why are metals called electropositive elements whereas non-metals are called electronegative elements? Name one element which has low melting point. Name the metal which is poorest conductor of the heat. Give an example of metals. This is a question which came in CBSE 2020 also. Is a liquid at room temperature, can be easily cut with a knife, is the best conductor of heat, is a poor conductor of heat. Explain the meanings of malleable and ductile. In the lecture I have spoken about their definition also and what do they mean. Differentiate between the metals and non-metals on the basis of physical properties. So these are the questions. First, try them. We'll discuss the answer. I will upload the videos regarding their answers also. First, you have to give it a try and answer them. If you have any doubt, you can ask me in the comment section. Okay. Have a nice day. Take care. In the next lecture, we'll discuss the chemical properties. Initially, we'll start a comparative study between the chemical properties of the metals and non-metals, so that as we did in the physical properties, it was a comparative. You were able to know that things easily. So we'll not do the metals first and non-metals first. We'll take both the things together. Okay. Have a nice day. Take care. I hope you like the lecture. If you want anything else, you can comment down and I will help you with that.